Hello, my people. Welcome to Smart Traveler Memos. Today, we will uncover one of the most fascinating tools in mathematics, the quadratic formula. Do you know this formula? X equals minus b plus or minus the square root of b squared minus 4ac all over 2a was inspired by the work of an ancient Persian mathematician called Al-Khwarizmi. Pronunciation might be a problem, but that is what the man was called, and he is considered to be the father of algebra. So guys, good evening everybody. May I take this opportunity to greet all of you wherever you are in this world, from Africa to America to Asia to Caribbeans, China, Japan, Australia, and all the other places. Why am I saying this? Is because tonight I have a very important assignment as far as mathematics is concerned. And since mathematics is universal, today I will be dealing with quadratic equations. And let's dive and see how I've arranged my PowerPoint presentation. So, the whole idea is to derive the quadratic equation formula. But anyway, guys, hello. Welcome to Smart Traveler Memos. Today, we will uncover one of the most fascinating tools in mathematics, the quadratic formula. Did you know this formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, was inspired by the work of an ancient Persian mathematician, Al-Khwarizmi, considered the father of algebra. This formula has been transforming the way we solve equations for centuries. Stick around as we drive it step by step and explore its real-world applications. I begin by showing you a visual diagram representing the real-world applications of the quadratic formula. And there you can see it is for your eyes only to interpret. But you can see that it is important in games. It is important in the market or business and so on and so forth. But we will be coming to these details in course of our journey. In deriving the quadratic equation formula, these are my highlights. First will be introduction, and in the introduction, I will give a brief history of Al-Khwarizmi. Then, in the same space, I'll do what quadratic equations are and where they appear in daily life. The second thing then I'll come to is the main crux of the matter, where I will derive the quadratic formula. And here I will start from the general quadratic equation, which is a squared plus bx plus c is equal to 0, where a is not equal to 0. Then I'll complete the square to arrive at the formula, and then I'll emphasize the importance of the discriminant b squared minus 4ac, which is under the radical sign. Examples and scenarios. I will solve using the formula equations which give me two distinct solutions, which indicates positive discriminant, an equation which gives one solution. The discriminant here is 0, and an equation where there are no real solutions, where the discriminant is negative. So the discriminant is what determines what type of answers you are going to get. In the same breath, I will highlight how to interpret results in practical context. Finally, I will do the applications where I will show motion problems, projectile motion, geometry, finding the dimension of rectangles or areas, and business and economics, profit and maximization. Let me now give the brief history of Al-Khwarizmi. So, welcome to Smart Travelers Memos once again, where we dive deep into the beauty and the power of mathematics. Have you ever wondered who came up with the quadratic formula? The answer takes us back over 1,000 years to the golden age of Islam, to a brilliant mind, Al-Khwarizmi. He is often called the father of algebra, and is the reason we can solve equations like this today. X equals negative b plus or minus b, the root of b squared minus 4ac over 2a. Let's explore his incredible story and how his work laid the foundation for modern mathematics. Stick around as we derive the formula and solve some fascinating problems. The brief history of this man goes as follows. Our journey begins in the 19th century in Baghdad during the golden age of Islam. Al-Khwarizmi was a scholar at the famous House of Wisdom, a hub of science, maths, and innovation. Sorry guys, I was just interrupted a bit, but we begin the brief history, and we continue and say that his groundbreaking book, Kitab al-Muqtasa fi Hizab al-Jabr wal Maqabala, introduces systematic ways of solving equations. Maybe you can pronounce those ones better than me. The term al-Jabr or algebra comes directly from his work. Not only did he formalize algebra, but he also popularized the Hindu Arabic numerical system, which brought us the concept of zero, a game changer for maths and science. In fact, the word algorithm, which powers you or favorite apps and devices, is derived from his name. We are even having an algorithm in YouTube itself. His contributions didn't stop here. Al-Khwarizmi also advanced geometry and trigonometry, laying foundation for astronomy and land surveying. Truly, his work bridged the gap between ancient and modern mathematics. So I managed to get the idea of how he looked like after I researched, and I got a postage stamp with his head. So that man looked like that, the father of algebra. And I also managed to get a page from the algebra of Muhammad bin Musa by Frederick Hussein, and that is the way it was from the archives. All right. His contribution to mathematics include the following. Number one, father of algebra. Decimal number system. Algorithm, geometry, and astronomy. So in algebra, he is remembered because the term algebra is derived from the Arabic word al-jabra, which appears in the title of his famous book, Kitab al-Maktasaf fi Hezab al-Jab wal-Muqabala, the compendious book on calculations by completion and balancing. This book introduced systematic methods for solving linear and quadratic equations. For the number system, he is remembered because of popularizing the Hindu-Arabic numerical system. And you remember that the Hindu-Arabic numeric system is the one which introduced the concept of zero to the Western world. And after the introduction of zero, this system is the backbone of modern mathematics and computing. Because without a zero, we could not be now listening to a PowerPoint presentation where I've used a computer, and you know the digits computer use are 1 and 0. In algorithm, this word is derived from his name, which reflects his influence on step-by-step problem-solving methods. And finally, he made a significant contribution to geometry and trigonometry, which were essential for astronomy and land measurement. His legacy, his work was translated into Latin during the 12th century and had a profound impact on European mathematics, leading to advancement during the Renaissance. His methods of solving quadratic equations have been defined but remain fundamentally rooted in these principles. His legacy continues to inspire mathematicians, scientists, and students worldwide. What are quadratic equations, and where do they appear in daily life? Quadratic equations are mathematical expressions of the form a squared plus bx plus c is equal to 0. Here, A, B, and C are constants, and A will never be equal to 0. X represents the variable to be solved. They are called quadratic because the highest power of x is 2, which comes from the Latin word quadratus, meaning square. To derive the quadratic equation formula, we start with the general form. Ax squared plus bx plus c is equal to 0, where a is not equal to 0. We will use the method of completing the square. So I'll take you through step by step. Step 1 is you divide throughout the equation by a. That each term you divide by a. And when you do that, you get x squared plus b over ax plus c over a is equal to 0. Step 2, move the constant term to the other side, and you rearrange, so that is, rearrange the equation to isolate the constant term, in other words. So that now the constant term is on its side. So you end up with x squared plus b over ax equals negative c over a. Step 3 is now you complete the square. To complete a square on the left-hand side, you take half the coefficient of x, square it, and add it to both sides. So let's do that. The coefficient of x is b over a. So if we square half of it, we will have half of b over a squared. And when we simplify, we get b squared over 4a squared. Add this term to both sides. So you get x squared plus b over a plus b squared over 4a squared equals minus c over a plus b squared over 4a squared. Step number 4 is you write the left-hand side as a perfect square. The left-hand side is now a perfect square trinomial already, and therefore you just pick the factor x plus b over 2a squared, which is equal to minus c over a plus b squared over 4a squared. So step 5, solve for x. We take the square root of both sides. X plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared. Simplify the square root, you get x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 2a. Number 6 is we isolate x, and this is done by subtracting b over 2a from both sides. So you end up by having x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. If we combine the terms as a single denominator, we are going to have x equals minus b plus or minus b squared minus 4ac over 2a. And that one ends our derivation or driving the quadratic equation formula, and our final answer is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Now, let's go to examples and applications. So, once we have the quadratic formula, the possibilities are endless. Let's solve three problems that highlight its power. We will have three problems, in fact, four. One problem will be giving us two distinct solutions. That is, two problems, will give us two distinct solutions. One problem will give us one solution only, and another problem will give us no real solution. We get negative discriminant. For one solution, we get discriminant is 0, and for two distinct solutions, the discriminant is positive. We will also see how the quadratic formula applies to real-world scenarios, from projectile motion to calculating areas and profits. And therefore, by the end, you'll see why this formula is indispensable. So let's start with our first question. Solve 2x squared minus 4x minus 6 equals 0. So the first thing is you identify the coefficients, and their a is 2, b is negative 4, and c is negative 6. And step 2, now you use the formula by substituting the values of a, b, and c. And when you do that, you end up with x equals 4 plus negative 8, 4 plus or minus 8 over 4. So if you solve for both solutions, the first one is you get x, you go the positive root, equals 4 plus 8 over 4, 12 over 4, 3. Number 2, go the negative root, x equals 4 minus 8 over 4, which is equal to negative 4 over 4 equals negative 1. So the final answer is 3, negative 1. Two solutions. And I also graph that equation. That is the graph of that equation, the quadratic graph. Question number 2 is you solve x squared plus 6x plus 9 is equal to 9. As usual, first thing you always do is you identify the coefficients, a1, b6, c9, and then you substitute them into the equation. Finally, you end up with negative 6 plus or minus the square root of 0 over 2. You find that when you simplify the positive root, you get negative 6 plus 0 over 2, which is negative 6 over 2, which gives you negative 3 as your x. And then if you take the negative root again, you get negative 6 over 2, and it will still give you negative 3. So you see the root is repeated. And in this case, the discriminant must be 0. So x is equal to negative 3. And that is the graph. You can see the turning point is at negative 3 on the x-axis. Sorry, I did not label the axis, but I think you understand what I'm saying. Solve 3x squared minus 5x plus 2 is equal to 0. We identify the coefficients. A is 3, B is negative 5, C is 2. Substituting in the formula, we manipulate and we get x is equal to 5 plus or minus 1 over 6. And solving both solutions, you get x is 1 and 2, x is 2 over 3. So this is another equation with the two distinct roots. That is positive discriminant. The first one did not have a fraction, this one has a fraction. And this is the graph. You can see the two values there. Now, let's solve x squared plus 2x plus 5 is equal to 0. And immediately we identify A to be 1, B to be 2, and C to be 5. If we find the discriminant, we find that B squared minus 4AC is equal to 2 squared minus 4 times 1 times 5 gives you 4 minus 20, which is negative 16. You find now the discriminant is negative 16 and is negative. Quadratic formula application. Substitute into the quadratic formula and you end up with negative 2 plus or minus the square root of negative 16 over 2. The key point. The key point, no real solutions. If the discriminant delta is negative, then delta equals b squared minus 4ac is less than 0. In this case, the square root of the negative, a negative number, that is the square root of delta, is undefined in real numbers, meaning the quadratic equation has no real answers. So for those of us who are still in the lower levels, as you go to the higher levels, now you find now we have other types of numbers which are known as complex numbers apart from the real numbers. So this is just a beginning of your journey in mathematics. So number 3 is you simplify the square root. In real numbers, the square root of 16 is undefined. In complex numbers, however, negative 16 equals 16. Negative 16 is undefined. In complex numbers, however, the square root of negative 16 equals the square root of 16 times negative 1 equals 16 square root is 4, while we don't know the square root of negative 1, so we leave it. But now, negative 1 in complex numbers is defined as the square root of negative 1, all right? And therefore, I equals the square root of negative 1, and therefore 4 root negative 1 will be 4i. So x is equal to negative 2 plus or minus 4i over 2. Simplify further, you get x is equal to negative 1 plus or minus 2i. The final answer, the solutions to x squared plus 2x plus 5 is equal to 0 are x equals negative 1 plus 2i and x is equal to negative 1, negative 2i. These are complex solutions because the discriminant is negative. There are no real solutions. Where do quadratic equations appear in derive? 1. Projectile motion. Next, business and economics. 3. Construction and design. 4. Physics and mechanics. 5. Gardening or farming. And number 6. Sports. In projectile motion, this is the path of an object thrown into the air. It follows a parabolic trajectory. For example, when you calculate the maximum height or time it takes for the object to hit the ground, it involves solving quadratic equations. In business, quadratic equations are used to model profit or cost functions to find the maximum profit or break-even points. In construction and design, quadratic equations are used to model profit or cost function to find the maximum profit or break-even point. Construction and design, architects and engineers use quadratics to design curved structures like bridges, arcs, or domes. Physics and mechanics, solving problems like stopping distance of a car or the trajectory of a moving object often involves quadratics. Gardening and farming, determining optimal dimension for planting areas, finding the length and width of a rectangular garden with a fixed area, and finally in sports, analyzing the trajectory of a soccer ball, basketball, or javelin through involves quadratic equations. So here I give the real world scenario. A ball is thrown up once with an initial trajectory or initial velocity of 20 meters per second squared from a height of 25 meters. The equation for the height of the ball at the time t is ht is equal to negative 4.9 t squared plus 20t plus 25. When will the ball hit the ground? That is when will h be equal to 0. So we are going to, since it is a quadratic equation, we use the formula and we find that t is 5.1 seconds, ignoring the negative sign, because time cannot be negative. And there we give the graph for the projectile motion, and we show you the ball hitting the ground when h is equal to 0. It will be 5.08499, right? Which is approximately 5.1. Business profit, a company finds its profit Px is modeled by Px 2x squared plus 12x minus 16. And then where x is the price of their product, what price will maximize profit? The maximum value of the quadratic occurs at x equals minus b over 2a. Here, a is equal to negative 2 and b is equal to 12. And therefore, when you calculate, you get the price that maximizes profit is at x is equal to 3 units of currency. And you can see there the maximum profit at the maximum turning point, x is equal to 3. Construction, a builder needs to create a rectangular garden with an area of 200 meters squared. The length is 4 meters more than the width. What are the dimensions of the garden? Solution, let the width be x meters, then the length is x plus 10 meters. So x times x plus 10 is equal to 200. You form a quadratic equation. X squared plus 10, x minus 200 is equal to 0. Use the formula and you get your answer as x is 10 meters, that is width, and the length is x plus 10, which is 20 meters. And that is the graph. Width where the curve cuts the y-axis, or y is equal to 0. When y is equal to 0, x is 10. Closing remarks. Mathematics is more than numbers. It's a way of building bridges from ancient scholars like Al-Khwarizmi to the challenges we face today. Just as he transformed the world of maths Running concepts like the quadratic formula can transform the way we approach problems in life. Thank you for watching. If you enjoyed this journey through maths and history, please like, share, and subscribe to Smart Traveler Memos for more content that makes learning exciting. Let's continue building bridges of knowledge together. See you next time. Mathematics isn't just about solving equations, it's about building bridges between problems and solutions, between challenges and opportunities. Just like the quadratic formula connects ancient algebra to modern solutions, learning maths transforms us, making us better problem solvers in all areas of life. Thank you for watching again once more. If you found this video helpful, please like, share, and subscribe for more exciting maths content. See you in the next one, where we will continue exploring the wonders of mathematics. And that is my acknowledgement. Those are the websites where I end up by thanking myself for the design and presentation. Goodbye, and see you in my next video.